Welcome to Center of Math's Images in Math series. Today we're going to talk a little bit about the Euler line. So the Euler line is just a line that's present in any triangle. It just says that the orthocenter, the circumcenter, and the centroid of any triangles are collinear. And there's a ratio between the two segments of the line of 2 to 1. And so to show that this line exists and this line exists and has that ratio, we're going to draw a little bit of a figure and show a few things about these points. So first, the triangle A prime, C prime, B prime. So this triangle is created by just finding the midpoint between each side BC, CA, AB, and drawing the lines. The three lines between these 3 points. Note that since A prime is a midpoint BC, then it's on the median of A going to BC. So in fact, it goes through the centroid. The centroid is labeled G. Note that, so A prime, B prime, A, C prime. So note that since A prime, C prime, B prime, similar to ABC, is just all 1/2. A prime, B prime is in fact 1/2 of AC, which is also equal to AC prime, and the same for C prime, A prime, and B prime, A. So this thing is in fact a parallelogram. And one property of parallelograms is their diagonals bisect each other, so A prime, A bisects B prime, C. So in fact, the centroid of our small triangle is the centroid of our bigger triangle. Next, let's note that, so the orthocenter of the smaller triangle, A prime, C prime, B prime, that's just where the altitudes of the triangle intersect each other. Note that these altitudes, they're perpendicular to B prime. The altitude going from A prime to the line opposite side B prime, C prime is perpendicular to B prime, C prime. But that's parallel to BC, so it's also perpendicular to BC, but also bisects BC. So the altitudes of this inner triangle is actually the perpendicular bisectors of the outer triangle. So that tells us the centroid of A prime, C prime, B prime is in fact equal to the circumcenter of A, B, C. So we labeled the circumcenter or centroid of the small triangle O, the common centroid G, and the orthocenter of the bigger triangle H. So it's a theorem we won't prove here, but it's well known that centroid, the median lines that intersect at the centroid, they in fact dissect each other in a ratio of 2 to 1. So AG to GA is in a ratio of 2 to 1. So 2 GA prime equals AG. And also the centroid, so AH, so ABC is similar to A prime, C prime, B prime, so everything's kind of just 1/2 in the smaller triangle. So this AH is in fact twice the length of A prime O, because A prime O is like that top half of the smaller circle's orthocenter line, and AH is the top half of the bigger triangle. So we have 2OA equals AH. We also have, since they're similar, and this is the base is parallel to this base, so these altitudes will in fact be parallel to each other. So we have AH is in fact parallel to AO. So since they're parallel, we have that this will give us the angle AHG. HAG equals angle GAO, because AA is a common line for both these triangles, and we know that AH is parallel to OA. So these angles, those angles line up, and we have these two sides are in common ratio to each other. So in fact, the triangle AHG is in fact similar to the triangle A prime GO. And since they're similar, well, we're going to have AGH, in fact, equal to the angle A prime G O. And so this actually proves that the 3 points have to be collinear. And so yeah, note the diagram wasn't drawn perfectly, which is why these points don't look exactly collinear. But if it was drawn exactly right, these would in fact be collinear because these angles do have to equal each other. And yeah, and because we know this triangle is in fact really twice the size of this triangle, the HG is in fact equal to 2 of GO. So that's where we get the ratio between those two. And so that's the main construction of the Euler line. We won't do it here, but this can in fact be generalized to other figures like parallelograms and tetrahedrons. They have similar lines of collinear points that you can examine. And yeah, thanks for watching. If you like this image in math, please check out the rest of the videos in our playlist. Thank you.